So, so you can have multi-index also, right? But now we are not continuing unit number 3 because, uh, guys, what we have planned for your midterm exam is uh, no, you'll be having unit number 1. Okay, that is basics, right? Again, um, then we will be having unit number 5. Yeah. So I'm gonna start right now. Unit number 5. That is very simple. Again, we have only 4 sorting techniques: bubble sort, quick sort, merge sort, and what is that next one? Selection sort. So 4 things, and then 2 searching strategies. One is sequential, and then another one is binary search. So this is just required 6 sessions. So we have 2 weeks left for your what do you call that? Midterm. Okay, so we will finish it, and then you will be having this one because we want other sections to be unique. That's why. Fine. And this is very simple. Today I'll complete bubble shot. Okay. Then you will be having unit 1 and unit 5. Along with that, you will have unit 2, something like this. Like array will be there. It will be completed in this week. So that we will let you know before your exam begins. You will get. Yeah, that's what I'm saying. That will be informed. I'm not sure about that particular unit. I don't know what it is. So it will be maybe only array, right? I'm not saying that entire unit 2 will be given. I'm saying that whatever the things completed, that will come, right? So you will be having unit 1 and unit 5 completely, and then in unit 2 we will let you know. I mean, sir will let you know, like until what you will get. Fine. So that's the plan. So after completing this unit 5, we will get back to that tree concepts. Then again we will because we have what do you call that here. Still, we have 6 to 7 concepts to learn, so it will take some time. So that before midterm we can't finish it. So that's why I'm jumping on. Yes, yeah. That's what we will. We will. Yeah. That's what AVL and these things will come. Height balance. So yes. So we will balance height B3. I mean, there is other name. That's what. Right. So let me begin with that. Already shared. Fine. So hope everyone can see this. In sorting, we're gonna learn these 4 types of sorting first of all. That is bubble, selection, quick, merge sort. Along with this, we will learn one. I mean, there are different other sorting methods. It is not in the syllabus part. Okay. So we will learn insertion sort also. Right? And then we will talk about these searching techniques. 2 different searching techniques and what are the differences. So basically, what is sorting first of all? Why we need to sort some elements? Why we need to apply sorting? Can you tell me a real-time example where we can apply sorting? Because of sorting, there will be some advantage. So where we can do that?
Like if we have a 50 students and if we want to find some particular student starting with name with the letter A, yeah, B, then it will help to write that. Also, if we look at if we have 1,000 images and if we sorting by date, yeah, size.
Yeah. So sorting again, you might have used Flipkart or Amazon, something like that. You will sort now. Always when you purchase something, high to low, low to high. So we will apply sorting basically over here. Like ascending order, high to low, and then it shows highest price first, means highest numbers. So like that. So sorting can be of 2 types, right? Either you can put it in ascending order or descending order. That's depends on the problem. So I have given one example over here that is called as a telephone directory, which means you might have seen a huge book. What if that directory is not in sorted order? it's very difficult. Already it is difficult to go one by one. Then anyhow, we will take some time and then we will find it. But if it is not in sorted order, then it's very difficult to refer that whole book. So that's why we put it in a telephone directory. And even dictionaries. You will look for some words, but that will be in, for example, one guy's name is Arav, AARAV. One guy name is Ajay. So which comes first? Huh?
Both.
Both. AA will go first. So likewise, you can enter 10 names and then you can apply sorting. So based on that, so this is called as based on ASCII values, right? ASCII, like A comes first, again A comes first. So we will put that as first. J comes, like 4 or 5, 6 like this. So like that it applies, right? So sorting plays an important role in our life, is it? Even your roll numbers are sorted in Excel sheet, right? It is not like roll number 1 and then roll number 10. It is 1, 2, 3, right? If I call something like that 1, 10, 15 randomly, it is not good, right? I mean, it won't be in a sorted order. I mean, and it won't be easy for me to mark attendance also. So if it is in sorted order, I can easily go for numbers in a sequential way. Fine. So let's talk about this bubble sort. Yes, and let me tell you that there are 2 types of sorting. Basically, that is one will happen internally and then one will happen externally. Internally, in the sense, I have this number of numbers, for example, 10 numbers, and I'm writing a program for it. If I execute the program, what will happen? Where it will be executed? I mean, the execution will happen where? Yeah, obviously, main memory. In RAM it will happen. But what if I have a huge crores of numbers, crores of user information I want to sort? I can't. I need a database. I need to store it either in hard disk or pen drive or CD or whatever it is, right? So that is called as external sorting. So where your sorting will get stored in some device. So that's it. So basically, what we're gonna do in bubble sort is also called as what is given in the first one, comparison. Right? So which means that you will be given a sequence of unsorted numbers. There can be 5 numbers or 10 numbers, whatever it is. For example, 5 is there and then 10 is there. So I will compare 5 with 10. So should I sort this? So I'll compare and then I'll check whether this 5 is greater than this or what. So this is 5 and then this is what is that, 10 or 15? 10. Yeah, 10. So I don't want to, I'll compare but I don't want to swap. Is it? Yes or no?
Yes.
So then I'll keep switching. If this is the first element is 5, the next element is 1. What should I do? I will compare 5 is greater than 1 or what? Yes, it is greater than this element. So I need to bring this 1 to the side. Swap. So I'm going to have a for loop, right? And then you might have printed 2 for stars, first star, 2 star, 3 star, 4 star, using 2 for loops, right? Like one for loop you will call it as I, and then another for loop is J. I is for the number of lines, and J is for printing. That's all. Right? So likewise, we can apply the same thing, and then we're gonna have a 10th variable. For example, I said I need to switch one of the element to the another position. So which means I need to store that one in a 10th variable, and then I will swap it. That's it. So just 4 lines of code is required for this. 4 lines of program. I mean the main concept, swapping concept. So and in general, let's go to that slide. So that is what I have given here. I will compare with the adjacent element, and then if it is less than this number, then I just swap. Else I won't swap. I will move to the next element. So likewise, I'll just keep on going on. Yeah. So this point is very important. If we have total n elements, which means I say 5 numbers, 5 unsorted numbers are given. Okay, then the thing is you will do n minus 1 comparisons. Means at least 4 elements you have to compare. 1 element will be sorted by automatically, right? So why the name is called as bubble sort? That is what given here. So for example, 5 numbers are given. 5 numbers are unsorted, random numbers. So first I will take the first number and then compare with the next, right? Then if I want to sort, I mean if it is less than, then I will keep on sorting. So in the first phase, I will get the maximum number to be in the last question. So that is why, I mean, we are just pushing the first, I mean, the largest element to the right side. I mean, the most right side at the end. So it is like when you, that is what they are comparing. When you pour water in a bucket or something, you will get bubbles. So the big bubble will come first, and then small bubbles will come. So likewise it is. So we are bubbling the big number at the, I mean, last at the end. That's it. Right. That's what the comparison is. So I'll just go to an example first, then we'll come to this. So let's take down this example. This is 15 and 16. I'll say 6, 8, 5. So this is the sequence which is given to you. Now, how many? What is the n value here?
5.
N is 5. So how many times at least I should compare? That is n minus 1 or n. Yeah, that is 4. Right. So what should I do first? So first I need to start with this. Like I will compare with this 16. Should I swap?
Yeah.
Why?
No.
I mean, if that 15 is greater than 16, I need to swap. I'll write some condition like that. If not, then it should not swap. It should keep as it is. Okay. So I'll keep as it is. 15, 16, 6, 8, and 5. Then what should I do?
16 to 6.
Yeah, I need to compare here. Then what will happen? Should I swap now?
Yes.
16 is greater than 6. So it should go to the right. Right? So I need to swap here. So what will happen? It will be like 15, 6, 16, and 8.
5.
Yeah, 5.
16 to 8.
Then what should I do?
16 to 8.
So now we are keep on moving on, right? In the, so for moving we need one for loop because it should keep on comparing. Then after completing this one entire pass, we need to start again comparing from the first. I'll let you know after this pass. So now I should compare 16 with 8. So what should I do? Hey, this is 16 or what? Ah, fine. Okay. So I need 8 and 16. So 5 will be here. Is it? Then I need to compare
16 with 5.
the 16 with 5. Then what will happen in that step?
15, 6, 8, 5.
8, 5, 16. So now do we have the maximum element at the end?
Yes.
Okay. So which means in the next time when I compare, so I can do only 4 comparisons. I don't, because 16 is already sorted. I mean it is there in the right side. So this is called as pass 1. So pass 1 in the sense from the starting element I have completely passed, passed one time, right? So I will say this as one time I have gone through this whole list of elements. So this is pass 1. So you can title this as pass 1 actually. Okay, pass. You can write it as pass 1. And then next I'll be doing pass 2, which means pass 2 in the sense again I need to. This is the answer from pass 1. So I'll take this one. I'll again compare with from the starting element. So likewise. So n minus 1 in the sense at least the minimum number of passes. I mean, I will get 4 passes. Sometimes it depends. Again, don't compare that. I always should get 4 passes. You might get it in 3 passes also. No issue, right? So yeah. So what should I do here? I'll just take this 15, 6, 8, 5, and 16. Now what should I do?
15 with 6.
Yeah. Now again I need to compare, right, from the starting element. So 15 and 6. It should be what? Change? Yeah, of course. So 6 should come here. And so we are swapping like this, right? So we will store this number 6 in temp, and then we will swap it. So that's why we need a temp variable. If we want to implement this one as a program, So 8, 5, and 16. Then what next?
15,
So again, 15 and 8 should be compared. Swap.
Yeah.
So 8, 15, and then 5, 16. Then
15 with 5.
15 with 5 again. So it goes like 6, 8, 5, 15, and 16.
Okay.
So I need to compare here, but I mean I'm not comparing, but I'm saying that yes, yeah. So now we have got how many sorted elements? Yeah, 2 sorted elements, right? Then
Pass 3.
so I need to take pass 3. So again for pass 3 I will take 6, 8, 5, 15, and 16. So 6 and 8 should be swapped. 6 is greater than 8 or what? No. So you just take as it is. 6, 8, 5, 15, and 16. Then
8 and 5, sir.
yeah, 8 and 5. 8 is greater than 5. So I'll swap 6, 5, 8, then 15, and 16. So what should I do now? What should I do? Actually, no, yeah, it is complete. But what your program will do? I mean, the loop will keep on going, right? And until it reaches the, until it reaches the index, the last index. So, which means that it actually compares again 8 and 15. No swapping is required. It will say programmatically. I'm talking about what your for loops will do. So 6, 5, 8, again 15 and 16. Again, it will compare with this. So here you should write that no swapping required. No swapping required, because no swapping is required based on the condition, because it is greater element is there in the right side. So fine. So now how many elements are sorted? 3. These elements are in already sorted order. Means 8 after 15 and then 16. So I'll go for, see, I have completed this pass from here. I have traversed to the end of this, that numbers. So in pass 4, what should I do?
6 with 5.
6, 5. I'll take that one first. 18, 15, and 16. So now I need to compare. Is it? So 6 is greater than 5. So it should be swapped. So 5 will be here. 6, 8, 15, and 16. Then it will be compared, but no swap is required. Again, for 8 and 15, again no swapping is required. 15 and 16, again no swapping required, right? So what is the final answer? So you need to show that steps also where no swapping is required. Then the final answer will be like 5, 6, 8, 15, and 16, right? Fine. So this is the answer. So don't say that I will write in first step itself all these things and without any passes, right? It can be, but we know that it can be sorted. But if you are implementing as a program, then the computer should do this particular steps. So we are instructing through a code to perform these steps. So that's what. So now, can you tell me the logic? So do you have any queries in swapping this publish sort? So publish sort is very simple, right? You just compare, take the first element and compare with the next element. But this, I mean, when you are comparing, if this element is greater than this element, then swap. That's what the concept is. And then keep on swapping. And then once you complete one pass, do remember that you have to write that this is pass 1, pass 2, pass 3. That is very important. Don't just make 10 steps and then this is the final answer. You have to say passes. How many passes you have got? In which pass you have got the answer, right? Okay. So now I want to implement this one in a program. So how can I implement using C program? I mean, tell me the logic only.
प्रोसेस शुरू करेंगे फर्स्ट एलिमेंट से और फिर उसको सेकंड और थर्ड.
Okay, let me write here for you. So first I'll take for loop. Okay, I equal to 0. Okay, then I less than n minus 1, right? N minus less than n minus 1, because we need at least 4. Then because why we are reducing it in the sense that we don't want to compare that one element, last element, because if you sort 4 elements, automatically one element will be sorted, right? So I'll say I plus plus. So this is outer loop, I mean outer for loop. For what? for these passes, pass 1, pass 2, pass 3. Then I'll create one more for loop, then where it should do this, traversal, like comparison, right? Yeah. So then again, I'll say one more for loop is there, that is j equal to 0 again. Then j again less than n minus 1. Then j plus plus. Okay. After this, what should I do? See, pass 1 is created and it has come here. Pass 2, sorry, in first for loop is about pass 1. This for loop I need to, loop, I need to do comparison. So while comparing these, if I were to compare 15 to 16, what logic I should mention here? Of course, yeah. If consider this as array, right? Now this is array, and I will name this array as a, and the index is 0, 1, 2, 3, 4. So I need to play with the index, right? So what should I do? If array of j yeah is greater than, yeah, I need to compare with the 0th index with the first index. So I need to say that it is j plus 1. I mean plus 1. It should go to the next index and it should compare. So which means that array of j plus 1. Are you clear in this? Yeah. Then what should we do? Yeah. So we need to have a temp variable. So I need to assign this value. Which value? A of j, the value to this temp. So now the temp will be holding some value, some number, right? Then what should I do? Then I need to swap, right? I need to send this number. For example, if I have 10 and then the value is 5, then I want to send this 10 like this, na? So which means that I want to send that one to that particular index. A of j equal to a of, yes, j plus 1. Yeah, and then that previous value should be swapped again. So now what I say that a of j equal to temp. Yeah, again, first the temp values assigning we are, whatever the value you have assigned, that should be come back to you. You have to swap in this way. Okay, so that's it. I'll just close, and now only the header file and then variable declaration, array declaration, all these things you have to do, and the program can be done. So this is the main logic for swapping. This is even very important for your placement questions. They will simply ask you to write a program for swapping or sorting. So that way you have to make it. So this logic should be there in your mind. And though that factorial program, how to make a factorial program. So these are all default questions. They simply ask you to. They just want to test your skills. And then if you are saying that I can do it in C or C++, they can say they will give you options. You can implement it in anything, but they want this logic. This logic is everywhere similar, in all the programming languages. So again, even without temp, we can perform this. So we can use other concepts. That is also possible. So okay. So I'll give you one more question for you. Yeah. So still, if I want to optimize this further, for example, you see this, j less than n minus 1 is there. There is some problem. For the first I value is 0, okay, and then it is entering into j. J value is also 0. So 0 less than what? N minus 1. What is the value? 0 less than n minus. What is n minus 1 here? 4. 4. So 0 is less than 4, right? So that's why it is getting into here and it performs swapping and all. Then it repeats. Okay. So after 4 or 5 times repeating, now the I value is here 1. Yeah. Then j value is 1. And then here what? 1 is less than 4. 1 is less than 4. Yeah. We have already achieved one sorted element in first pass. Yeah. Then again, do we have to compare here? No. So what I do is that I'll minimize one step. To further optimize this, what will work? But if you want to optimize, because 16 is already sorted, And then in the next step, if you see this, two elements are sorted. So here you can minimize two steps. Likewise, you have to keep on minimizing. So you need to pass I value over there. For example, if I value is here, this I value can be passed here. So you just say minus 1 extra minus 1 minus I. So if I value is 1, so j value is also 1. J less than n minus 1. What is n minus 1 value? 4. 4 minus 1 again. So you will do only 3. 0, 1, 2, 3. You will ignore this part. So you can minimize one step over there. I mean, if you want to optimize further, then that can be done over here. So you can say that here j less than n minus 1 minus I. Right? So we will implement the same program in the laboratory, same concept like this. That is a simple program, which is here, right? Fine. So, and then try what I said over there. Without that, minus I, with minus I, with temp, without temp. So we will perform that one. I'll let you know without temp during lab session. Is there any queries in this bubble shot? So take down a question for you. I have an exercise task for you. It's just, I have 50, 40, 30, 20, and 10. Please perform bubble sort for this. Huh? Default. and you can trace it by having this program. You just compare, your input with the program so that you can trace the output. So now, what do you understand from bubble sort? Can you tell me what you get from bubble sort? What do you write in your answer paper? If a question is given, explain bubble sort. What do you do?
We can arrange reading the ascending order and also descending order. Descending,
We need to change that condition. Right?
yes.
Then, so you need to start adjacent element. You will compare. You have to compare with adjacent element. Guys, who are online, please give a try and let me know in which pass we have achieved the result.
Or pass. What can the
And still, we can introduce a flag variable in this program. I mean, after doing all such comparisons, if the element is sorted, it will again check for it. That to reduce that step again, we can say flag variable. We can introduce flag variable. That we will do. Okay. Yeah, you will be getting info. Yeah. I have admitted everyone who's waiting. Hope he is there in the session. Yeah, and passport, that's the answer. Fine. Yeah. Someone is asking, someone is raising the hand. Ash Desai. So, is there any queries in this bubble short? Yeah. So, I wanted to show you what do you call that? Online visualization for this. So, you can try this website as well. I'll just put that one in the chat box. It's here. Okay. So what I do is that you can visualize it online, like how the swapping is done. It will display some coding part also for you. This is the one. Fine. You see this? I'm going to create a. What is the answer? I mean, question which I have given. Yeah, 50, 40, 30, 20, and 10. Right. So I'll say go, and I'll put this one in slow mode, and you just click go, and you just say sort, and so now you see this. If the element is greater than, then shift. Like what we are shifting, it is performing the same thing. So now pass 1 is completed. Now it is going for pass 2. If you want it to be very slow, you can adjust the pass here. If you put slow, it will do it slowly. Right? Huh? You don't understand anything? So it is just performing sorting. The numbers are taken and now it is performing. See, these are all sorted. Yeah. So now you will achieve. So now the start equal to false. So that's why I said we can use flag variable over there. And there is one more visualizer also. That is also, I mean, if you don't understand this part, you can use this one. Right. So here it is asking for array size. Is it? So see, you can practice all these sortings here itself. There are. Right. It is taking a lot of time. So for in this website, for most of the concepts were implemented, data structures and other concepts are implemented. You can explore this website. This is very useful website for you. I mean, you can visualize it. You see, this lot of concepts were there, and you can give a try, right? What happened to this website? Okay. So here you can say bar. I mean, what kind of layout you want? No, I want bar. So let me have these elements, or I will go for what do you call that? 50, 40, 30, 20, and 10. So I'll just run. So you see this, it is taking 35 steps in the sense that all comparisons it is taking. So I mean, you just see this. So first it is going to start, and it has indexes 0, 1, 2, 3, 4, right? And now it has taken the first pass. I mean, here it is like pass number 0, and it is going to move the element. You see this, it has taken 50 and 40, right? It is comparing now. The explanation is strong here for you. So you have to compare, and swapping is done, right? So likewise, again, comparing the element, swap is done, comparing, swapping done, comparing, swapping done, and then this is pass 1. So we have put the greatest element at the end, pass 1 is done. Then pass 2, pass 3. So you can visualize even here. You can use this website. Fine. So it goes on like this. See that? I'm just doing it like this. So at the end, you will achieve it. That's it. So this is for your, understanding. You can use this website, and then you can perform other sorting as well. But make sure something might be wrong. I mean, don't believe that everything is right here. Whatever is shown in the, you have to cross check that. Huh? No. I mean, maybe they might have changed some condition in the programming in the background, so that it might show different results. So don't believe that results that this is the exact result. You just cross check it, right? Learn the concept first, and then try to go through it. All right. So I'll go for attendance now.